in part B, we're asked to find the tension in the string. So how I consider this, you can consider as two separate diagrams. So you could either consider particle P. So let's try particle P. So I want to find the tension in the string. So again, we're still going to use F equals A. So to find the resultant force, so it's traveling, particle P is going in this direction. So the 40 will be larger, so 40 minus T and minus 10 is equals to the mass of P, which is 5, and we know the acceleration is 3. So we have 30 minus T equals to 15. So we know T most equals to 15 newtons. We could also consider particle P. You would get the same answer in the tension. So if we're considering particle Q, again, we know the direction traveling is to the right. So tension, so the forward direction is just tension. Then minus your friction, which is 6, equals to mass, which is 3, times by your acceleration, which is 3. So again, your tension in the string is 15 newtons. And finally, part C, explain how the modeling assumption that the string is light and inextensible have been used. So the word light has been used. The tension is the same throughout the length of the string. So the light just means that tension is the same throughout the length of the string. And the mass of the string is negligible. Because it's light, so we have ignored the mass of the string. And the word inextensible has been used in here, means acceleration of the masses is the same. So when it's inextensible, that means the acceleration of the mass for P and Q is the same acceleration. So again, we can consider this as one particle because it's moving on a straight line. So now let's look at another question. So Newton's third law states that for every action there is an equal and opposite reaction. So what does this mean is that let's say we have two bodies. So if I have body A and body B are in contact, so if body A exerts a force on body B, so let's say I have a force from body A exerting on body B. Body B exerts a force on body A that is exactly the same but opposite. So let's say the force A exerts on B is 10 newtons. Then the force B exerted on force A is 10 newtons upward. So this is Newton's third law, that every action there is an equal and opposite reaction. So let's look at this problem. So we have a light scale pen is attached to a vertical light inextensible string. So the scale pen carries two mass A and B, and that the mass of A is 400 and the mass of B is 600. So remember that with our formulas, we always work in kilograms. So we always need to convert our solutions to kilograms. So this is same as 0.4 kilograms, and this is the same as 0.6 kilogram. And so we have a sketch of the diagram here. Then we ask to find out, we know acceleration is 0.5. The scale is raised vertical up, so the acceleration is going up by 0.5 meters per second. So part A, we want to find the tension in the string. So again, just using our Newton's second law, so F is equals to ma. So we know that it's going upward, and that the resultant force would be, so call this tension that's pulling the scale up. And we have, so what's pulling it down? We have the weight going down. So we have A has a 0.4 G, and for the second block it's 0.6 multiplied by gravity. So weight is pulling it down, and tension is pulling them up. So let's work out our resultant force. So the force going up is just our tensions pulling our particles up. Minus, so since it's going up, so we know this is a bigger number, so we're always using the bigger number subtract the smaller number. And going down, I have weight of 0.4, gravity, and minus 0.6. And it's equals to the total mass, which is 0.4 plus 0.6 multiplied by acceleration. So this is what we want to find out. So just add them up. So I have tension minus, so minus 0.4 minus 0.6 is just minus gravity, equals to 0.4 plus 0.6 is 1. So this equals to acceleration. So we can work out our solution. So we know that acceleration is 0.5 equals to 0.5, and we know gravity is equals to 9.6. So minus 9.8 equals 0.5. So our tension is equals to 0.5 plus 9.8, which is equals to 10.3 newtons.